Oh, right. I'm instantly streaming. That's the thing. That's the dealio. Hello, hello, hello. Oh boy, have I been making some headway. So, if you. What did I just do? I didn't know that was a thing. Control S does that. Okay. So, if you were following what I was working on yesterday, I have been working on a Shiny application to visualize the world's turtles. This is what I have right now, and it's actually been massively improved in the last like couple hours. So basically, it takes a map. These are all of my regions that I've created. And what you can do is now select a phylo region. 45 is the US. And what it'll do is it will update it. It'll filter the phylogeny, only show species that are relevant to that phylogeny, as well as all of those species and kind of where they're at. Now, what I want to do today is I really want to update this script quite a bit. So, first thing I want to do is really focus on the map, because this is kind of nice. The phylogeny stuff is nice, but not strictly needed. What I want to do is I want to add a few layers to this map. So I already have a topographic map. I think I want a better one, but I also want to add in some bioclimatic variables. So certain things like, here, let me also get this YouTube going, because I forget that I really should be trying to stream more on Twitter. So boom, 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 boom. Let me grab this. And then I'm going to pop this on. Streaming some data visualization stuff over on YouTube's. Basically making a Shiny app that shows that will help me interpret results from this turtle phyllo regionalization results. Turtle phyllo regionalization and endemism results. Cool. Okay. So like I mentioned, the Shiny app is actually a way more developed than it has been in the past, so I'm super excited for that. Now, I do want to add in just a couple more layers. So one of the first things I want to add in is I probably should add in my canopy results. So those are these results. I want to add in basically this is a shapefile. This shouldn't be too difficult to add in. In fact, let's figure this out really quick. So I have here, not there, I don't care about, maybe I do care about it. Hydrophilo cluster, blah, 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 blah. No, don't care about this. Cool. Close things, close things. So I'm also trying to just do way better practices in R, way better everything. Edge out, phylo region create, not really needed anymore. Phylo region visualization script. This is probably not even needed anymore. I'm just going to close it. So let's now open up another file. This file is going to be the let's see if it's in Canopy Classify. Yes, it is. Okay. So did I save this data as anything? Of course I did not. Oh, this is fine. Okay. Boop, 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 boo. Oh, let's close down the server. Make this a thing. DF Canopy. Did I not just run this? Okay. And so, boom. Okay, so now I need to load in the hydrobasin data, which I believe is this one. So this should add in something just called hydrobasins. Just called hydrobasin. Did not. Let's do previs jack R data. Okay, we'll just do it on HydroSimp. Okay, well first off, we need to add this into here. So that'll make everything a lot easier. Now where it says HydroBasin, Control-Shift-Alt-C, no. Control-Shift-Alt-M, there we go. HydroSimp, so if you don't know what I just saw, that's Control-Shift-Alt-M, keyboard shortcut that allows you to edit everything at once, and it is awesome. Okay. So first off, let's drop that. Let's get an XY going. Let's get our ggplots. I think this might already be perfect. Might. Keyword. No applicable method. Fill factor XY. Let's just see. It might have been because this was small. That's kind of a known error in R. No, I'll keep it here. This is actually the best spot for me. I just want to make sure it plots with the stuff. I don't care about all the little nuances yet. I just want it to plot. That's all I care about. So XY is a simple features. And also what I'm doing right now, okay, perfect. Okay, so then also what I need to do is I need to save XY into file equals, outputs, canopy, shape dot data. Okay, and then also now I can load this in up on my main script. This is just so that I can always have everything. So load outputs XY, perfecto. So now what I need to do is XY is added into here. So I am just, you know what I should do? I should actually name this properly. So let's just say XY is equal to, let's do this, canopy, make it all lowercase. Canopy, canopy class is XY, and then we'll save that as, because XY is just non-descriptive. Okay, boom. So, cool, so now we can add into here, canopy class. So do you see how I'm doing all of this though? So basically this function save and load should be some of the most useful things you ever use in R. It's going to help organize your entire life. What you can do is you can save objects in R as into a single file. So this file is going to contain 1, 2, 3, 4, 5, 6, 7, 8 different objects that I can then load in at the start of my app right here and then use. So now then, here's what we're going to do. We're going to go to region plot. So this is the most important part. Now then, now I need to add in an extra shape. So if I add in tm shape, and this shape is going to be, actually the way I'm doing this is kind of dumb. Let's just do sfsimp, eliminate this. Okay, boom, and then canopy class, and then added tm polygons. Nothing. Okay. I think that'll work. We'll find out in just a second. So this should now add another layer, that is those file regions that I just added on. Now it's going to take longer to load the first time, but my hope is that every single time after this it's going to be much faster. That's what I added in some reactive elements, because the only thing I need to do now is just hide and show things. Maybe I should also simplify this. Maybe not. Maybe I can simplify this more, because this is already taking a good amount of time. And the last one took a good amount of time. So, which one am I using for this? So, HydroSimp. Again, I just want to make sure it loads properly, and then I can work on making this way simplified. Which I would then simplify. And I'm actually going to pull this off into my other pane really quick, just to let it do its thing, while we do all of this over here. And then let's now add in the same MS Simplify script that I was... Oh, and it's frozen. Give it a second. We should give it... Okay, there we go. It actually loaded up. So, now... Let's see. Over here on Layers, if I take away Canopy Classification, exactly the functionality that I wanted. The problem is Canopy Class is just very, very... big, so let's now add in 45. Yep, perfect. Didn't even edit anything. We do need to remove Canopy Class. Okay, perfect. This is exactly what I wanted. Okay, so now let's make this way simpler. I know y'all can hear that. The garbage trucks are the loudest things in the world here. Trying to find the exact script I used to simplify. I know it's just MS Simplify. I just wanted to make sure. Okay, and it's from our map shaper. So let's do that. So let's do this, Canopy Classify. What we're gonna do is we're actually just going to make this very easy, and we're going to grab this, add this over, Canopy Class. I like simp because, you know, hey, there's nothing wrong with a little simping every now and then change this over to XY. So let me show you the benefits of simplifying things. So this is something, if you're working with geospatial data, you should always be doing this, especially just for visualizations. Maybe not for the exact analysis if you need it. Simplifying basically takes all of these geometries and just makes them simpler. That's it. That's all it does. So if we have this one, so let's say, okay, let's run this function. What we can do is we can actually look at how big an object is by going to object size, XY, and there's a way to just, I think we can just divide it by 124. That'll change it over from bytes to kilobytes or megabytes. It's in kilobytes, so we need to convert it to megabytes to be something a little bit more understandable, because we never talk about things in terms of kilobytes. We talk about things in terms of megabytes or gigabytes. This is just me getting very nerdy. And simplifying does take a while, but I promise you it's worth it in the end. Because it's like, every single time you mess with this, it's going to take forever. So I'd rather have it run forever once than run forever a million times, you know? It's running right now. While this is going, I'm actually going to make me a second cup of coffee at the moment. So let's start grinding up some coffee. So, is this still running? Yes, it is. That's totally fine. While we wait, again, I'm just going to make me some coffee. But yeah, this is running properly now. Oh, right, the reason I like me over here... Oh, it finished. Okay, so let's do this example. So, object size of XY is what? This isn't bytes, it's actually megabytes. So it's like, it's a lot of bytes. So if we divide it by 1,000, it's 118 megabytes. Wait, if I just, wait a second. I'm just curious about something. Yeah, so it's a lot of data. So this is actually, so this isn't bytes, this is megabytes. It's probably like 11 gigabytes of data. Now, if we simplified it, we now simplified it down into Canopy Class Simp. canopy class simp, we can now see that it is literally a fraction of the size. So instead of being 118,000 megabytes, it's now 15,000. That's why we simplified it. And this also means that if I wanted to plot it, so canopy class simp, it will plot much faster. Now, it's not going to be fast because this is still like crazy data, but you saw that was seconds instead of like a full minute earlier. Sorry, I know this stream is not very ASMR'd perfectly, but that is fine. I'm also just going to flip this because I'm realizing that it is better. Okay. Okay. So now we have that. Cool. Okay. Now what I want to do is I want to go to here. So we go to TM shape, TM polygons, color equals NA. I think this will work. In fact, I think I can just run this without having to do a shiny. I'm just dumb. I'm just dumb. Okay. Plus TM fill call equals NA. What I want to do is I want to make sure that it doesn't have the borders, because that's what gets me messed up. Boom. Cool. So this should open it up over here in this plotting window. What I'm hoping that it'll do is that it'll plot it, one, faster, and then two, without all the borders, because that's kind of the issue that I'm running into. And this TM stuff is TMAP? TMAP. So let me actually look up the documentation for TMAP really quick. So TMAP borders transparent, which I just found TMAP. Draws polygons, fills with polygons, either fixed color, color palette, TM borders. Okay, so it is in TM borders. I need to make this. So for TM fill, for TM borders, the single color value specifies for line color, full color. Okay, so what we're gonna do is we're gonna do TM border and then alpha equals 0. That's what we need to do. See, it's still gonna take a while. Which are omitted. One TM layer has duplicate layer types. To draw multiple layers of the same type, use multiple layer groups. Specify TM shape to each of them. Right. So again, this is exactly what I wanted. It's showing what I wanted. I'm not worried about it. And then also I want to put the canopy class below this, so we need to do that first. Let's see here. Let's go to... I literally lost where I was just writing all this down. Right here. So we're going to do TM borders. Nope. I actually will still need that. So alpha equals 0. And then we'll also add in TM fill. So this is coming from canopy class. Oh, I also was doing the bad one. Oopsies. Simp. And then I want it to do it based off of... I think I just type in for this one... Oh god. Okay. Classification. That's what I'll do. So TM fill call is equal to, oopsies, classification. I don't know if this is the right terminology for this particular thing, but we're about to find out, aren't we? Could not find function TM border. It probably is TM borders. Object classification not found. So can I do it? No. Okay, TM fill based off of group. This is what I'm trying to do. So TM fill based on group variable. Okay. I know what to do. It's just like there's minor differences between all of these. So okay, so it is just I put it just in quotations. Because this wouldn't work in, like, ggplot. Because in ggplot, you just input the actual name of the thing. So... And now it should plot faster. I was accidentally plotting with a incorrect plot. I was doing the one that was not simplified yet, and that was the issue. So, see, already faster. Not doing what I want it to do, though. Not at all what I want it to do. So... Okay. So we have class simp, we have the polygons, it's rendering out the polygons, then we need to find... Okay, yeah, take it one step at a time. So, okay, so tmap, transparent borders. That's what I want to do. Alpha should be working. So why is this not working? So if I'm just gonna remove TM fill for now. We can always add it back in just in a second. But I do not know why this is not really going the way I want him to. Because I want them to be just totally transparent borders. But I'm getting warning messages, and that's not working. Okay. One TM layer group has duplicated layer types, which are omitted. I'm just double checking some things. So SF simp, that's fine. Canopy class simp. I don't know what this warning message means, so let's look this up really quick. Yeah. Huh. Okay, so... but it feels very inefficient. Seems to me that you want to write less code. You can specify which columns you want to use in TM polygons. You end up having 4 maps at the same time, however, you do not have to code a lot. So then... Oh, I can also simplify this further. So, what we're going to do is we're going to do call is equal to classification. This might help out. This might help out. This might be what I want to do. Haha. Okay, it is classifying them. If I remove that, perfect, it hides it. But why is it still showing the borders? TM borders alpha not working. I mean, like, I not sure what's going on here. So I don't get why there's TM fill, TM borders. Oh, is it because I'm making a TM polygon? Oh, TM polygon, no border. I think I get it now. So what I think I'm doing, what I think this is going on, is that it's drawing the polygon, and then it's trying to make something that is just the borders, right? But then I set it to 0, so that's where it's saying duplicates. So if I look into TM polygons, border.alpha, that's what I needed. Okay. Border.alpha equals 0. Okay, so now we just remove that. And then this will work perfectly. This is exactly what I needed to do. This is so good. Okay. So yesterday with this code, all we did was we set up the basic principles. Love it. Absolutely love this. I can set up the color palette if I so choose. A name of a data variable that's contained map colors, in this case map coloring, a palette. By default the alpha name palette. So I can work on the palette. I can make this way better, but I'm not really gonna focus on it too much. So yeah, so first off, I want these to be at the bottom. I think these should be at the bottom. So we're just going to reorder it and then put it up at the top. So plus equals, okay, cool. Now this is just going to reorder it because whenever you're making things in R, it stacks them one by one based off of your top order. So it's kind of, you basically just got to think about it in reverse. So this first TM shape is canopy class simp, which is what we're looking at right here. And I want that to be on the bottom, so I need to put it on the stack first. Then the next layer is going to be the polygons. So just as reference, if I run this, what we'll see is a reversal, and we'll actually see our regions plotted over the endemics. Which you can see there now. And this is, oh my god, this is exactly what I needed to see. Oh my god, this is exactly, holy shit. Holy shit, this is what I needed. Fuck yeah, bro. Okay, so my next bit to make this even better is I now need to add, ooh, almost tipped over my coffee, some bioclimatic variables. So that's the next key to this, so that I can then on the same map see all the bioclimates. And then, kind of I think once I have those variables, what I can then do, once I have those variables in there, what I can then do is actually set up the data and make it look so much nicer. This is exactly what I needed. Oh, I'm so happy. I am so happy. I'm just like kicking ass on this project. And the nice thing is this exact visualization I can then use in the future, but this just gives us so much of a better understanding of what's going on. Like, look, this is exactly what I'm seeing. So it's like, why is region 57 a region? Well, if we look at it, we see these, oh my god, this is so cool. We see that there's a lot of paleo endemics here. Well, now, let's actually run this on the full Shiny app. Because this will show exactly the logic. So data visualization is not just to show off your research, it's actually meant to be able to help you visualize and understand your research. So let's go back into it, right? Interesting. Lots of interesting. Okay, wait. So let's just continue this train of thought, right? So we're exploring the data, we're trying to understand it. Oh, interesting. Region 57. Why is that pulling out? So we have paleo endemics here. Interesting. Well, if we look here, oh, we have Kenosternon and Scorpoides over here. No idea they got all the way down there, actually. We have a Mesoclemis, which I think this is a paleo endemic here. The next thing is to actually start coloring this phylogeny based off of this result. That's kind of the goal. We do have some Hydromedusa, which is on its own kind of thing. The Hydromedusas are probably these paleoendemics. You see they have a very long branch. Same with Mesoclemis. Holy shit, I can actually interpret my data now. Fuck yeah. Fuck yeah, bro. Okay. Yeah, or over here too. So what, region 56 also looks like it has some mixed endemism. Like, that's just kind of segregating it out. Same with this region 57. Wait, this is also research 57? Oh. How interesting. So these are clustering together. Interesting. Okay. 56. Let's just look at this really quick. So not many species. Has some edge species, nothing too crazy. But we have a mixed endemism, so that means there's a mixed neo and endemics. It looks like these Phrynops. Right, Hydromedusa also popping out. Well, this visualization, I think, is messing up a little bit. Okay. Okay, Madagascar. Here's a really cool region. So it's like, what's going on here? Well, region number 17 is its own wild, wild thing. It has super endemism and paleo endemism. And if we look at things a little bit better, yeah. Peloceos, Pelomedusa. Yeah. Perfect. Okay. Well, let's just work on making this visualization the best it can possibly be, and then we can work on all of the little things. But this is also going to help us identify areas of conservation concern. Next thing I want to add in is I also want to add in the edge, and then I want to add in bioclimatic variables. Those are kind of my goals for today. And then these background maps, these are the ones I need to figure out this, like what these are, and then make them a little bit better. So, and then if there's a possibility, I would like to add like an alpha slider for each layer. That would be the coolest little thing, right? But, okay. Baby steps, right? So all of this was accomplished one step at a time. And it doesn't cost me a dime. Probably losing money setting all this up. Okay. Okay, so canopy classify. This is all good. We're saving the simp one. Again, very important to make sure you're saving all of your variables properly. So we're saving the simp one. So that means that whenever we get to here and we actually want to... I don't think we even need to plot anything. Canopy class simp. Okay. Done. Okay. So now let's do... Should I just add an edge right now? Should I just add an edge right now? Let's do it. Okay, recent files. This might be in post hoc. Threat. Wait. Do I already have this loaded? I mean, I do have mean edge for every single grid cell. Hydrophilo cluster. Oh, this one does show the mean edge. Okay. So the thing is, I think I already have this in here. So SF simp should include their edge scores. So SF simp So we'll keep this here. Now we'll add it another layer. Tmap, tm, shape, sf simp. Okay, so this is what we'll do. So name is equal to edge score. PR mean score. So now we're just going to get a little bit more explicit with how we classify things. So name is equal to PR. Borders up here, this is what we'll do. We'll name this. Name is equal to. So HB, so what we're doing is we have hydrobasins, which are HB, and then we have phyloregions, which are PR. That's really what's going on here. HB canopy. PR means score. And then what we're going to do is we're going to have a TM polygons, and then call is equal to mean edge. So I also think that I should keep this. Hold on, we don't need all of this data. Okay, there we go. So then this should just stay up here. So then we can eliminate this, call mean edge. Cool. Plus. And then what we can do is now we can also make a count one. So this will cause it to load longer. So p on PR count of edge, and then we'll make this mean edge. And so then this one will be based on count. Now then, let's just test this because I just added like 2 new things and reorganized stuff. So it's good to test often, or else you'll realize that you added 100 things and you don't know where the mistake in those 100 things are. I'm very excited for this. This is the data that I have been so excited to make. Cool. So these are kind of hideous, but that's fine. So let's just remove some things. So this is the count of edge species. Yep. Let's look at now the mean edge score. This feels so good. Let's add on the borders. It doesn't really matter for that because they're already all borders there. But basically it's because this is on top now. So yeah, this is how we identify regions. So the problem is I need to now add alphas to all of these. Oh yeah, red means null values, so we can just kind of ignore it. And these are the hydrobasin IDs, so it is going to look kind of ugly, but that is all fine. So let's do this. Okay, so I think I'm going to make the alpha 0.3 on all of these. I think that's been my best bet. So basically alpha just describes how transparent something is. So if I, sorry, I keep looking over here because I'm used to my camera being right here. Right here. But now it's here. So it's on my other side. So I don't even realize it half the time. Oh, I need to stop this as well to make this run faster. Also, I'm listening to this playlist. You're high on mushrooms in the Viking Age, and the gods are everywhere. This is the type of shit that I fuck with. Okay. So now we have a better idea. We can actually look at our results a little bit more cleanly. So if I remove canopy, let's also just remove, let's keep it as mean edge score. We will remove the borders, fuck it. But then let's say we want to highlight region 45, which again is the US. I use it because it's very big, very visual. I will need to adjust all the colors of these, that's totally fine. But hey, let's look at the world topographic map now. Oh, yeah. Okay, cool. Now, let's work on getting the data set up for the file regions. So I did just get these, so let's now, we have a raster stack. So the problem with working with spatial data in R isn't necessarily, to a degree, it's learning how to work with spatial data. The problem is that you'll have to learn how to work with like 3 or 4 different spatial data types. So I circumnavigate that by, instead of learning what a raster stack is, I then just say convert raster stack to SF. SF, convert raster layers to a simple feature. Can I just do this STSSF? So, what is a raster stack? Okay, wait. Let's just try this. So let's try st as sf. We'll do w, and then let's just do this as biocode. Let's just see what happens. Maybe it just does it perfectly. Yeah, that's kind of what I figured. Okay. A raster stack is a collection of raster layer objects with the same spatial extent and resolution. Perfect. So let's just say that we have we have W. Okay. So I can access them with each of these. So let's do that. Let's just say this is bio1 is going to be st as sf. Let's see if we can convert a single raster layer into it. No. Okay. Okay. st as sf for raster. I know of 2 different ways to do this. It's so weird that they're saying I need the stars package to make this work. Read stars. I mean, what I can do is I can probably convert it to a spatial object. What? So this guy has his own STSSF converter raster. Why doesn't STSSF have this, though? This is so weird. Converting SF. SF. Oh no, raster to SF. Okay. Convert raster to SF. Convert raster. It's kind of weird that this is raster. Okay, as. Okay, yeah, we'll just do the double trick really quick. So what I can do is I can do y. Okay, so let's do w. We'll add it as a pipeline. We'll do as dot spatial. So this will convert it to an SPDF, and then we'll convert this to st as sf. And then we'll output this into, we'll just name it bio for now. No method for converting raster stack. Okay, so let's do it for each one. So let's just say we're going to do it for bio 1. No for converting raster layer to spatial. Okay, convert raster layer to spatial. Oh, wait. R, convert raster to polygon. I've done this a million times. Raster to polygons. Okay. Well, let's not do it in a pipeline first. Let's just make it work first. So let's do it in bio 1, and then let's do it as raster to polygons. just name this bio. Just see what happens. We need to just do some data exploration to figure this out much better. Studying like a scholar in the Baroque period. I don't want a 2.5-hour long playlist, though. I want something that's an hour. When you reveal the psycho you really are to the person you've been dating for months. True, though. Very true, though. Okay, so this is going to take a while. Raster to polygons, which is fine. I did make the resolution kind of big. I should also be plotting this, because I have no idea what this looks like. We're going to have to wait for this to run. I just want to add the bioclimatic variables, just because I think it's going to add a little bit of extra information. So bioclimatic variables, let's actually discuss this, because this is perfect. So bioclimatic variables, I'm using WorldClim data. In essence, it is WorldClim. It's one word. WorldClim. So these are maps that are for the global climate. Now I can download these. I could totally just download them instead. But they have all this weather data that we can then use. So bioclim. So let's look at. So I use bioclim instead. It's a factor of WorldClim, but bioclimatic variables. So there's 19 of them. So it's annual mean precipitation, mean diurnal range, isothermal, seasonality, annual precipitation, etc., etc. I'm only going to keep a few of them in here, because, like, obviously I don't really care about, or I probably don't care about precipitation of the warmest quarter, driest quarter. Really what I need is probably annual mean temperature, temperature seasonality, possibly min temperature, annual precipitation, yeah. And then I also want to add elevational data to this. So I can do all this with the get data package function. I'm just now realizing, is the resolution... Yeah, you want higher resolutions. So this is taking a while. Raster to SF object. Maybe I do just need to do that with stars. But it's saying that it can do it with stars, but that's not... So this guy has the raster in here. But I'm not reading it from a path. Okay, so maybe raster to stars are. Maybe that's what I need to do. STS stars. Is this? Let's look at the example. That doesn't even show it. Okay, because this is taking too long for me. This is taking too long, and then let's terminate R. It's time, especially with shiny apps. Things just sometimes get weird. But this is why I've been saving everything, so I am not worried. Not really worried, anyways. Gotta love our studio. Gotta love our studio. You're Mexican. You don't look Mexican. What am I supposed to look like? A quesadilla? Like, that's good. That's pretty good. Okay, okay, cool, cool. We're back. We're back. We're back. Okay, we're going to save all that. We're going to set up this data. Now we're going to go to... Let's do it... Let's make the resolution 10. Okay, I need to load in all the packages, which is fine. Okay, let's get the biggest data that we can. 10 meters. Yeah, I don't need anything. Okay, it's not that big. It's not that big. Okay. So now I saw that there was ST as star. Was that it? ST as star in stars. Okay. Do I have stars downloaded? I do. ST as stars, and then we're going to do that as W. And then I just want to see if it plots properly. Oh, I don't even know if this will work because it's a raster stack. Oopsies. Oh, but it worked. What? Did it take each one? Wait, no way. Okay, it only took the first one. So let's make sure that it's, let's do the first just by 01. Okay, that's much faster. Okay. Let's just plot this really quick, just see what happens. Yep. So we can see lower values up at the top, higher values in the center, with what we expect from mean temperature. We're gonna go with it. Okay, so now if I do ST as SF stars bio. This should just work. Oh my god, that does work. Oh, this is taking a long time to plot, though. This is taking a very long time to plot. Okay, but I know I don't need basically any of this. Ugh. I mean, if it's an SF object, it'll be very easy to plot. Although, do I need to... I want to convert it to SF because this is what I'm used to using. Also, I'm just cold today. This is taking a very long time to plot. Okay. For this one... Oh, it said it finished just now. Maybe I will just keep it as a stars object, you know? So if I do tmap stars, does that work? Oh, yeah, it could work. It also can do rasters. Maybe I just don't even worry about this, yo. Yo, I'm just gonna keep it as W. Cause fuck it. W10. Because obviously this is just giving me trouble when I don't really need to do this, so... boom. Oh, so yeah, R might crash again. Which I'm not, like, upset at. It's a very data-intensive process that I probably don't have set up perfectly. Okay. So now we got W10. W10 will come into here. So now, let's just add in another one. So, boom, we have TM shape, W10, and then, if I'm understanding this correctly, I should be able to just add in TM polygons, and then call is equal to bio1. Again, it'll plot down here, and what I'm hoping for is a layer that just shows bio1. That is all I'm hoping for. It'll be named W10, but I think it'll only show by 01. Oh, haha, it's not a polygon, it's a raster. So the difference is rasters are grid cells, which are like a lot less computationally intensive to plot than taking every grid cell and making it a polygon. Grid cells, you just can draw them super easily because they're basically lines on a map. They're just faster. That's really the ultimate reason. Also, I do not need this line of code anymore. Wherever you can. So in case it's also not clear, the way I'm making this work is that I'm plotting this with tmap here, but then this tmap I'm feeding into leaflet, which allows me to actually visualize. If I didn't do leaflet, then I wouldn't be able to move around and highlight and get tool tips and stuff like that. So, okay. 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 So let's just do this as, maybe that'll help, because I guess I am feeding it all of those. Maybe that's the issue. Okay, down sampled it, which is fine. Where is it though? It might be because of the color argument, because it was being weird. Variables in it contain positive and negative values. Huh. What happens if we just did this? So no leaflet, no everything else, so that works. Is this maybe leaflet messing up? Okay. Leaflet raster tmap. Yeah, this is not working out the way I thought it would. So, I mean, I can add it. Yeah. Raster not showing when passed to leaflet. R. Huh. Not gonna lie, I am a little confused as to why. Was it just taking its sweet time, maybe? Because I should be able just to. It should just be a thing that I can filter. Okay, you know what? Actually, can I make this a? Okay, okay. Let's look up some of the basics of leaflet really quick, because I have a different idea for this. Okay. So leaflet tiles. Okay. Leaflet in our basics. Create a map. Add layers. Add default OpenStreetMap map tiles. Okay. If you're not familiar, here's the equivalent. So okay, add raster as a tile in leaflet. How to I think I get it. Okay, so leaflet tile. Leaflet tile R. Leaflet for R. Okay, so let's look at this add tiles. So add tiles. Let me see, what can map be? A map widget object created from leaflet. Okay, well, we have tmap leaflet. This is a whole other thing. X, a tmap object. Okay, that's what I'm all doing here, and then I'm creating that tmap object. Add tiles to leaflet object. Maybe these aren't actually tiles? Okay. Interactive layer display. So they have the leaflet, whatever. Okay, so we can, okay, so tiles, which is what we looked at earlier, can be add tiles, yes. Add tiles, so a map widget object, the HTML. So if we add the tiles, so they're doing group. So what if we did this? So what if we did, okay, add tiles, and then, yeah. So add tiles, W10, bio1, and this would be the data is equal to this. So, and then what we'll do is we'll remove this from here, even though I'm really not sure why it's not working, but whatever. Because if I can add it as a tile, I think I'll be okay. Could not find function add tiles. Really? What? Oh. hoping this will just add it on as something I can like turn on, turn off. Like I'm hoping it just works. But it did not add it as a tile. Which is fine. You know, we're trying to figure this out. So, add tiles. Okay, so leaflet add raster as tile. What if I just let's try just adding this. So add raster image. What happens if I do this? Like what does it look like? Like I want to know. I just need to be able to turn it off is the thing. Turn it on, turn it off. That's ultimately the goal. So, ooh, lots of issues. But it is there. It is there. I mean, it is behaving like I hoped. But I want to be able to toggle that on and off is the issue. That's the goal. And I'm like wondering if I add it as tiles, that doesn't do anything. Okay. Leaflet toggle raster. How to hide toggle legends with layer conditions. Display. No. I did see as tile, so maybe. Let's see, you can add legend to the same group, it'll show legend polygons both. Leaflet, data, fill color, add polygons, add legend. Add layers control. Overlay groups, GTM, and then max. So, if we do this, and then add layers control, we just say overlay groups are equal to, let's also just do this, so overlay groups and then options. I'm gonna copy and paste because I'm feeling lazy. Okay. Okay, now. Oh, how interesting. So I just lost all of my abilities to filter anything. Ha. And yes, sorry, OBS is just being annoying. Maybe it's this group parameter that's needed. The problem is this example, they named the data and everything the exact same. I'm just trying to also understand. This is like an exploration for me, so it's meant to help me.
Sign the form.
What's up?
Sign the RSVP form.
Why?
Because
I'm gonna be there.
you need the Zoom link.
Huh?
You need the Zoom link.
I can get it from you though.
From the Zoom link.
Send me the form again.
Okay.
Okay. Nah, this isn't really what I'm wanting to do though. Okay. Leaflet toggle add raster image. Oh, you know what I'm thinking? What if I actually make this on the server side? What if this is on the server side instead? And we make it in this observe event. I can do that. Okay. I think I figured out a solution. That's a little bit of a workaround. But to me, a solution is a solution. So, okay. So, what I'm thinking is I now add in onto here a fluid row which file or region. Okay, cool. And then what I now want to add in here is a new select. Select. Okay, wait. So I want to make this a checkbox. R shiny checkbox. Checkbox input. Checkbox input. This one is going to be bioclim, and then what bioclim variables. And here we'll have it just as C bio1. Bio1, and we'll also make this bio2. Just to have it in there. And then, boom, close this fluid row. So then what we're going to do down here is we're going to... Okay, let me actually just collapse a few of these, make it a lot easier to figure out what the hell's going on here. So then we're going to add in an observe event. Observe event input bioclim. And then what we're going to do is we're going to go to leaflet proxy, get the region plot, remove shape where the layer ID is equal to bioclim. Then we're now going to add on this raster image that we have here. We'll add it down here. Hold on, there's a couple things. So we're going to add raster image. We're just going to keep it like this for now. And then we're also going to do a layer ID is equal to bioclim. I think this is all we need to do. Okay, so let's update the UI, update, valid, oh shit, okay. Input ID. For now, we're gonna eliminate that. I just messed up. I just did something stupid is all. but it's fine. It's fine. It's fine. It's fine for this test. Get this plotting. Obviously, I need to add some wiggle room with this. But what the thing is, I should be able to just hit this, and it's going to... It's still adding the raster layer, but it is updating it. But why? Okay. Okay, wait. Observe event shiny checkbox. See below, observe event input test. Observe event input bioclim, and then update observe event ignore init. I think this is what I need to add. So if true, ignore. And then I need to wrap this. If input bioclim is equal to true, else I think this should work. The logic makes sense to me. Basically, it's just saying that if it's false, remove the thing. If it's true, add it. It's not there. And then it crashes. Let's look at this a little bit more closely. Okay. Let's actually just add this to the top. And then I can worry about it later. We'll play with like true and false and stuff like that. Because at first it wasn't plotting it, which is good, but I want to be able to plot it when I hit this checkbox. That's the goal right now. Oh. I was just too hasty. Okay, hold on. Okay, false. And then what I want to do is add this here. Okay, that should do it actually. Oh, I haven't posted on Instagram today. Okay, let's see what my stuff is at. Okay. So it's plotted. No bioclim variables. We'll give it just a second. We plot it. Ooh, bioclim variables are now set. Uncheck it. It should be removing this. So you see how it like flashes whenever I do that? Only when I'm clicking true. That's because it is removing it and then adding it. But unfortunately false is not removing it, and I don't know why. It's not a shape. Wait, is remove though an actual remove? If it's false, remove raster. Okay, so let's do leaflet remove raster. Yes. Clear image. That's what it is. Wait, is this right? I think I got it figured out. Okay, so let us now close this visualization server. Boom. Once I have this, then I can just start adding a shit ton. It'll actually be a lot easier this way. Oh, I'm so excited for this. Again, it takes a second, and that's fine. Okay, cool. So now we can click it. It should add it without issue. Cool. Look at this shit. Y'all, this visualization is fucking sick. So, look at this, right? Oh. This visualization is so fucking awesome. Okay, so here's the map, here's all that stuff, right? I added in a few layers, so now I can actually look at things like my my canopy results, right? Or I can now also plot onto it bioclimatic variables, such as mean temperature, and just remove it at the click of a button. Oh, it takes a bit to plot because it's big, but again, fully movable map. Oh, this is so good. This is so good. I'm so happy. Okay. So now let's try to get this to a point of done. Let's try to get this to a point of done over the next couple hours. That's sort of the goal. Okay. So first off, we're not anymore adding. So let's add in bioclim 1. We'll call this bioclim 1. Fluid row. Okay, this is all fine. So then, checkbox input. We'll make this a couple. Ooh. Okay, so now it's just basically repeating what we've been doing. Cool. And so then we're just gonna add a couple more checkboxes. Okay, so we'll add in bioclim 4, and then bioclim 4. And then let's look up the bioclim variables that we want to add in. Oh, I also want to add an elevation. Okay, elevation. Okay, so let's do the bioclim variables. I'm not going to look at too much bioclim data. Let's add in, so annual mean temperature. Let's add in bio4, yep, which is temperature seasonality. Boop, 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 boop. Let's do bio12, which is annual precipitation. And I think we'll cut it there, and then we'll add an elevation. So then, bioclim 1, group bioclim 1, layer ID bio1, perfecto. Bioclim 1. Okay. So then, I also need to get the elevational data, which is not too big of a deal, honestly. So, and then after we add in this elevation data, I think we're just going to focus on making it look good. So bioclim 4, 12, and then input elevation. So let's also get the elevation data really quick. I believe elevation is equal to get data. Let's look up get data really quick. So get data, get geographic data, name, alt, world, clim, see details. If data is world clim, CMAP 5, model. Okay, R get elevation data. Raster. I feel like this should be in here somewhere, but it might be just elevator. Get elevation raster. From the elevator package still. An SPR raster. I just want to get the worlds thing. Function utilizes terrain tiles. I might be able just to make this a lot easier. Leaflet elevation data. Let me just see. I'm trying to find like mass elevation. Like that's kind of the thing. Okay. Elevation raster. R. I don't want a point. I want the whole thing. Let's not worry about elevation just because I don't want to worry about it. And this is just meant to make my life easier, basically. So, cool. So now let's update these for 4 and 12. So here we go. So Bioclim 4, Bio 4, Bioclim 4, Bioclim 4, 4, 4, 4, group, Bio 4, layer ID, Bioclim 4. Cool. Input, Bioclim 12, region plot, Bioclim 12, Bioclim 12, Bio 12, Bioclim 12, Bio 2, 12, boom. And that should have just now added 3 more rasters. So now if I open up my Shiny app, yep, I got Bioclim 1, 4, and 12. So we can look. Argument is of length 0. Okay. So we have some variable that's messed up, and that's fine. Bioclim 1. Remove layer. Okay. Bioclim 1. That might have just been the issue. Let's add a space here. Okay, I think that was the issue, maybe. Why is this giving me errors now? Okay, let's make sure that it's just on that one. And then maybe I messed up something, which is totally likely because I mess up all the time. Huh. So Bio 4 and Bio 12 work. But not one. Interesting. The one that we based Bio 4 and Bio 12 off of. Okay. Maybe it's in the UI. Bioclim 1. Ooh, I do have capitals here. No, that's just the label, though. So we got Bioclim 1. Okay. So observe and map if it's false, blah, blah, blah. Remove Bioclim 1. Layer ID, Bioclim 1. Group, Bio 1. Bio 1. Layer ID, Bioclim 1. What the fuck? Come on. This is so dumb. So you're telling me this one will work, but not this one? What? They're the same! This is bullshit. They're the same, man. Come on. Input Bioclim 1. If it's false, remove it. Cool. Or else go to the region plot, remove image. I'm wondering if it's just messing up on this remove image thing, which doesn't make sense because the other ones work just fine. What the fuck? They're no different. Hold on. Let's rerun server just to make sure it's not something stupid. This is so fucking stupid if this is... There's no difference. This is so fucking stupid, man. Okay. Okay, and now I can also remove it. Bioclim 12. And I can remove it.
Here it is. Here it is. Here it is. Here's the issue. Done. Okay. So fucking stupid, man. What the fuck? Okay, that should work. Then if this is working, then I think we can just focus on making this much cleaner. Like, organizing it a lot. Mm-hmm. If I choose a filer region... Oh, no. Oh. Okay, a couple of them don't work. Which is fine. So there is something going on with this large phylogeny that isn't subsetting properly. That's something I gotta fix. Let's worry about organizing this just a little bit better. So here we go. So first on the UI front, let's get the UI all set up. Also, let's just save everything since everything is working. Okay, so UI, we have the title panel. Then we have a fluid row, which we should make this a column. We'll make this width equal to 4, just to go with it. And then we'll have this select input, blah, 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 unique. Okay, close that column. Now we have another column with width equal to 10. Let's just make it like that. Jesus Christ. Okay, and then in here we will have a fluid row, which is where we will now add in all of our checkboxes. Not seeing any errors. So this should just make it to where the checkboxes are now, like, not there. But, oh wait, let's check it here. I want the checkboxes to be next to one another, and I want them to be in their own column. And everything still is going to work just fine. Basically, this should be over here. And I'm not sure why it's not working. Okay. So they have their own column. Oh, it might just be that the column is too wide. And so it's putting it down below. Ah, okay. But I want these to be next to one another. Like, this isn't the end of the world, but it's just how I want it. So let's do this. So shiny UI, put check, put inputs next to each other. Not above. Side by side. Yeah, it's this side by side thing that I'm not sure. In a row, yeah. You could use fluid row, column, column, and add columns. Oh, well maybe I need to make sure that this... No, because I do want these next to one another. Yes. No, that's not really what I'm looking for. Oh, each of these needs to be in its own column. Okay, no, wait. So this one has a column, and then what we're going to do is we're going to add. Boom, boom. We'll make this 2, and then we need to add on this. Okay. Okay, that should work. I'm assuming. Oops, I need to close down this. I wish I could update it in real time, but I also understand why you can't. That's just like one of those like little quality of life things. There we go, baby. Probably shouldn't be fucking with that before it's all loaded in. So let's make these all a lot closer. I think I'm gonna make the column width for each of these 1. And then make the column width of this 4, make the column width of this probably also 1, because it's not needed. But will they overlap? They do overlap too much now. Okay. So we'll make them all, we'll make this one 2, and we'll still keep this one at 6, and then just keep it at 2, 2, 2. 2. Okay, cool. It's just little things now. This is the stage of the project I really like to be at, because I can just really relax and not worry about all these minor particulars. I do need to push this over just a little bit, offset it all. Yeah, the data takes a while to load in, but once it's loaded in, it doesn't take that much longer. So we can now just do it like this, BioClim 1. Maybe I want to work on making the BioClim data much easier to read, but that's fine. Which phylo region? 32. Okay, cool. So I do have more. Okay. So I do have a little bit more width over here, so we can make this 3. I'll keep this as an 8 and just see what that does. Also, let's make the RShiny app open up much larger. Okay. Make RShiny app size open. I don't know. Fluid page server run in a dialogue, run in a viewer pane. I think I just gotta call it here. Okay. So yep, so now I have a little bit more space, which is fine. So even if I do a big phylogeny like in 45, there's still plenty of space. This... What if I actually put it below the map? Made it a vertical one? Kept the same look, but didn't make it a circle. Okay, well, 1, I do not need these anymore. So basically what I'm saying is remove plot output for tree full here, and in essence, put it here. Let's just run that really quick just to see if it's doing what I think it's doing. Let's also make this width equal to 1200. Let's see what that does. But what I'm hoping is that the map will now be below, or the phylogeny will now be below the map, which it is. And now I can use this whole space down here and make it a more condensed view. Okay, cool. Also, if I keep this width, will it just make it wider? Unused argument. Okay, let's see. I'm sure there's a shiny app. Shiny app width. I just want to change the application size. You know what? Super minor concern, not going to worry about it at this time. Let us now... One, I also need to fix this full tree. Whatever. Let's change this layout. Let's go into the GG tree documentation really quick. And figure this out. Okay, so... GG tree documentation. Because GG tree is what I'm using to actually make these trees. So, I think I know there's definitely a layout that I want. I actually probably have it open already. Let's just remove a lot of my questions that I was having. So, yes. So let's make this a... Okay, so we are going to make this a I, which is a... That's ellipse. So if I make layout ellipse, and then I can just add on chord flip to this. Chord flip. Now, okay, we're getting there. We're getting there. It is doing the full length. Ellipse is definitely incorrect. I think there's an issue on here. Oh yeah, they got it mislabeled. A B C D E F G H I J K L. A B C D E F G H I J K L. Okay, so we want it to be a cladogram. I think I just don't have a layout then. Yeah, okay, let's remove the layout. Yeah, so no layout, just no branch lengths, and then chord flip. I can't wait to show this at lab meeting on Friday. It's gonna be such a subtle, not even a subtle flex. It's just gonna be a flex. Like, yo, I did this. Okay. I do need to fix labels, but that's fine. Yeah, labels are all fucked up. And also this has so much... I don't want it to be between both of these. I want it to be directly underneath the region plot. Ooh, there's the issue. There's one of the issues I was running into. Okay, so we got the chord flip, which is perfect.
Now, what I want to do is I want to like scale the trees a little bit. Rescale trees. Okay. Labs, caption divergence time. Okay. What does size do on a tree? What if I just did size equal to 2? And I think I can just do it here. So definitely not that. Okay, size is equal to 0.5. Now, why are the labels there? Oh, that's because TipLab 2. Yes. Okay. And then GG tree. Oh wait, I'm actually doing that on tree sub. Hold on. Geom tree scale plus geom tree scale 40. X is equal to 40. Aha! Okay. Okay, GG tree geom tip lab rotation. I really just want to rotate the labels, and I'm just forgetting how to do that. Da, 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 da. Okay. So within ABS, subset is equal to ABS angle. And then, so do I just add this here? So then angle is equal to 90. Is that all I need to do? Aha! Yeah, that's all I had to do. Okay, let's make the size a bit smaller. That's not really what I'm wanting, though. It might actually be fine. Let's see what it looks like on the application. Because the application's a lot wider than that is, so it might not be an issue. Yeah, see, it's not that big of a deal. The only thing is I want to be able to push this up now, and also, yeah, now I should have less issues. If I go to 45, for example, boom. This is where they are on the tree. They are quite small, but that's also kind of a problem with the phylogeny itself. Huh. And also on this phylogeny, I want to be able to add the major clades. So like, just be like, this is probably the testudines is my guess. Which is actually pretty easy to do. So do it, yeah, like
just to make it a little bit visually clearer. No, this isn't the Testodines. I wonder what this group is. Okay, well, what happens if I scale it backwards? What does that look like? Will it like push it from the bottom? That's what I wanted. Okay. GG tree hide legend. I don't need that. Uh-huh. No, I want it for GG tree. Okay, so it's within the geome. Probably here. So then what? Show dot. Oh, that makes. Will that work? No. Yeah, that worked. Let's see how this looks on this on the app. Okay. Looks slightly better, slightly worse. I just don't understand why there's so much space, and I don't know why this isn't staying underneath this column. Like, I want it to match up here. Did I mess up somewhere in here? So this is all within the UI. And it is within its own column. No, it is not. That's why. Okay. So let's make this actually 30 now. I think that will, fluid row. Yeah. Okay. So yeah, I was just messing up, which sounds like something I would do. Now it should stay underneath just the map. Oh, my music stopped. Time for me to listen to something else. I'm kind of tired of the classical. Beautiful, mommy. Okay. I wonder if I should maybe just do like a fan approach. Because also this size should be bigger. Let's make it, instead of that, let's do a 45-degree angle. And see what that does. Yeah, the problem is when it's like two species that are really close. So if I did something like 45, I bet it's going to look really bad. Yeah. Really bad. I mean, truth be told, though, what I might be able to do is just get rid of the labels and make them instead. Hold on. Why don't we just do it as geome tip points? And then AES. Wait. Yeah, AES fill is equal to red. So basically just get rid of the labels, because I just now thought that if I add the grouping to it, I really won't need the labels. Because I know what species are in here with the subsetted tree. This is why you do not get rid of things. Red, then show dot legend equals false. So yeah, let me just try plotting that. Okay. Now let's try plotting this. Yep. Okay. And then offset y. Okay, so geom tip point y offset. H just, so what we'll do is well, it's flipping the coordinates, so I think I would still do H just is equal to 0.5. Let's make it equal to 5. Maybe it's not in aesthetics. Ooh. Okay, so this is not in aesthetics, that's why. Okay, so H just is equal to 5. Unexpected symbol. H just. Okay. So it is just offset. It is just offset. 5 is going to be excessive. No, it's not offset. What? I'm looking through a lot of documentation right now, and I don't know why. Like, they have offset and everything else, and it's just not doing anything. Yeah, this is weird. Missing argument to function call. What? Oh. Well, I just added that. So maybe it is. So just making sure H just doesn't work, V just doesn't work. So what the fuck do I do then? Yeah, okay, H just option and geom tip point. There's none. The points be prepared data from the passage. I did just that. Size equals 4. How to put the points, for example. Geom tip point. So AES. So they're saying here is actually x is equal to x plus 1. Really? That doesn't seem right. That's right. Okay then. Kind of dumb in my opinion. Okay. But yeah, that works. Okay. So now I need to add all the clades onto here. This is going to be some good data viz. Okay. So ggtree interactive. Okay, so explore a tree in R. Find phylogenies in R nodes. Find paths of a node. Okay, so I do want to highlight a clade, which they do offer some really good things. So displaying root tree, modify color tree, displaying labels, root edge, blah blah blah. I want to highlight a clade. So GG tree highlight clade. Okay, yeah, so we do have a highlight clades, which is just geom highlight, and I need to find the node. Okay, so our tree is this one. So for now, let's do geom node lab. Literally doing nothing. Clade lab. But it's not showing the node names. This is just I don't know why this isn't working. This is so weird. It should just be okay. Oh, so it is geom text. This is dumb. Why have that function then? AS label equals node. Cool. So now what we're gonna do is I'm gonna go through this in like subset. So basically we'll figure out what 374 is, we'll figure out what 672 is, and that's how we're gonna do this. So it's not gonna be perfect, it's gonna be really messy, but that's fine. So let's see. GG tree. Oh, so I actually do this. I do this actually. So extract clade. So we're going to extract the clade based off of this. So I think I should be doing this in some bullshit thing. Okay. So we're going to extract .clade the tree at 374, and then what we're going to do is just a GG tree. Boom. Okay, and then we're going to add in geom. What was the end label again? I forgot what the geom tip lab. Geom tip lab. Let's make this size equals 1. And then let's zoom in on this. Thanks, Plot Zoom, for still making it impossible. I don't need exact, I just want generally what's going on. Caladina, Amidura, Mesoclemes, Caladina, Phrynops, Mesoclemus. Okay, so clades of turtles. Maybe I can just group it into the families. Okay, let's group it by family just to make this a little bit easier for me. Okay, so Caladina, Chelidae. So this is the Caladinas. So, what other genera are in Caladina? Elzea, Amidura. Okay, so we can say that this node for sure. They have the Acantho, Acanthochelis. Okay, cool. The Sniffpello. Okay, so I need this node right here. That's the node I need. Okay, so then let's add in a geom text. So node number 134 is the Chelidae. So what was I doing? So I go to here. And now I'm going to do geom node. No. Okay, what was highlight clade? Again. Okay, no longer need that. No longer need that. Okay. Geom, just highlight. Okay, just highlight, and then node equals. Okay. So then geom highlight node is equal to 134. Fill is equal to gold. Is there a way to add a label to this? Geom highlight. I'm really just wanting to make sure there's a label. So for example, if I just do this one. This should be highlighting all of this section over here. Why is it not? Why are these different? That's fine. This is the issue. So now we're also going to need to add in okay, I know this is a thing, so now we want to add in a label, geom clade label. How about we just do it as geom clade label and be done with it? Clade label So we'll just say color equals gold, label equals 0 Daira. So now it adds this, and then if we zoom, okay. So basically it's just setting it up for the first one, and then after this it'll just be a lot of copying and pasting. So offset 8, align equals true. Okay. Offset, we'll keep this 0.5. No, actually we'll keep 0.8 because we'll have the points underneath that. Yeah, what is in geom clade label? I just need to get all of the little... Because, yeah, I don't like where it is right now. Okay, so let's just do offset dot text. I also need it to move over. H just. Perfect. Okay, H just is equal to negative 0.5. Or just 0.5 apparently. Boom. So many data. And now we need to make size equals 2. What? Font size. Jesus Christ. Everything is different. Sometimes it's font, sometimes it's size, sometimes it's... Okay. We'll make this 4. We'll make this 3. We'll make it 3. Alright. So font size, label, color, offset text, align true, all that's going to stay the same for the most part. So let's move label over to here. And then we can just copy and paste. Cool. Okay, so this next one will be 410. And let's investigate what this is. So at 410. That's really fucking annoying that like this node number doesn't stay consistent. Like that's really fucking annoying. Wait, what? So now we have... I'm confused. Okay, so on this one, this should be 410. This one, 375. Okay, let's see if maybe there's an issue with extract clade. Let's also get my fucking music going. This is a very hard turtle visualization. Okay, let's do Desert Treehouse, Dust Rider. Realizing we're living in a... Ooh, Those Who Ride with Giants is pretty good, though. Okay, so then, extract clade not keeping node labels. I don't think I can find it, and that's just the way it goes. Okay, let's continue on. So if I do this, we know the label is 374. So now this next one is Palomedusa, probably its own family. Let's go back into Wikipedia. Also, I will show you what I'm doing here. So, this is the one we just figured out. We just got the Chellids. And now we need the... No, is Podo? Is Podo and Palo in the same thing? They are. Okay, that's fine. See, but the issue here is that, like, I want to be able to actually look at this and see. So can we make this interactive? Aha. This is fucking stupid. Okay. So we do need to figure out the Podos. I'm almost tempted, though, not to for now, because I can always add it in later. And if we go back to this tree, we can see that the clade belonging to 375, this one is Podo... Hold on, what was it? Podonemidae, Podonemidae plus Palomedusidae. Medusidae. We can work on the little nuances at a later time. Fuck though. I'm just like, it just makes me nervous because it's like, it's so easy for me to make a mistake here. Like it's really fucking easy for me to make a mistake here. Okay, well let's now look at 471. I think this is the way we're going to have to do it. We're going to have to consult here and then immediately go into it. So if we do 471 here, what is it? So these are... Rhaphitis, Apollones. Okay, so let's look into our Wikipedia. Wiki, where'd you go? Okay. So these would be in... is it all Trionychidae? Got a few different ones, a few different things. So it has Apollone, it has Cycloderma in here. Cycloderma, I think so. Nisso. Okay, so this is Trionychidae. Okay, so this is easy enough. Okay, so 471 is Trionychidae. Let's just... Okay. So... 471. Oh. Almost messed up. Almost already messed up. Okay, so 471 Trionychidae. Is that how you spell it, Tryon? No, it is a lie. This is what we're doing, though. This is the way we do it. Okay. 471, let's look at 505. What is 505 gonna get us? 505. Kina Sternens. But let me. I think Kina Sternen has more species, though, does it not? Yeah, do I have Sternotheris on here? I do not. Wait. Are these sea turtles down there? Hold on. Oh, weird. There's this clade, which are the... Oh no, here's Sternotheris. Okay. So yeah, this is all fine. Okay, so I need to find the one that is 1 up, 2 up, 2 up. Okay, so it's not 471. I think it's 479. Oop. What? What? Oh, that's because I just did that. We're in the 505s. Okay. So let's try 515. There's probably better ways of doing this, but I don't care. Okay, so 515 is going to be Kinosternidae. Okay, so 515 Kinosternidae. I love Kinosternens. Okay. So then if we look at the bad one, what is in 510? So 510 includes Chalidra. Okay, so I need to find the one, I need to find the sister to 515. I have a feeling this is going to be 511. Just looking at this data and how it's structured. Okay, we're starting to understand it. So now 511, this are your snapping turtles. So this are your snapping turtles, Jesus Christ. So Chalidridae. So the way I figured out that just now, I know it's kind of easy to not understand what I just did because I didn't verbalize any of it. So if we look at this plot, now again, these labels are not properly matched up to these labels, which is really frustrating. But if we go to the end, so what I saw here though is, so we know that this clade right here, this 40 clade, these are your Kinosternens. These are your mud and musk turtles. I keep looking at the wrong way. Apologies. However, if we look here, so this is the clade we're extracting. This is 35, but it's actually 511, or 510. 510, apologies. If we look at the clade that we want to get, which is this one right down here, if you can see my mouse. Oh, you cannot see my mouse. Oopsie, sorry, this made no sense. So this right here, let's zoom in. Basically, all that I'm doing here is, whenever I saw this, I was like, what's going on here, right? So we have this clade, we have this 40 clade, so everything from 40 downwards we have. The issue that we did not have was we knew 35, we know this one is 510. We needed to get this clade right here, okay? This one right here. 35, 36. It's one more. So the order is staying the same, just the numbers are different. So 35 to 36 is equivalent to 510 to 511. Ergo, I use 511. Easy. Okay, so now we can keep going down this kind of chain. So I knew 510 is the one we were looking at. We were actually looking at, what were we looking at? We were looking at 505. So if we look at 505, cool. So now we see that down here, these are the sea turtles. 41. This is going to be 506. These are going to be your sea turtles. 506, sea turtles, which are Chelonidae. Chelonidae. Cool. Okay. So back to it. Let's actually just replot this tree. Okay. So now let's look into 544. What do we got? These are our emmets. I believe. Are terrapins? Terrapins are on their own thing. Okay, Wikipedia time. So this did have emmets, so Emetidae. However, it also has are box turtles in Emidae? No, they're in Geoemidae. Right. Where are they? Wait. No. Let's open this up. So they are in here. Terrapins. Okay. Platies. What the fuck is this thing? Wait. Platysternin? What the fuck is that doing here? Hold on. Platysternin, big-headed turtle. In the family, Platysternidae. No backlink? I'm wondering if this is a monotypic. It is monotypic. Geoemididae. I'm gonna lump. Hold on, can I do that? Is that possible? No, that's not possible. So this would be the emids. Also, let me just check this really quick. So 65 up to 82, that's a difference of 17. So add 17 to this, so that's 461. Oh my god, among men. Okay, so 561. Apologies. 561. So 561 are your emidids. Okay. 561 emidae. Is it just emidae? Emididae. I was like, this sounds wrong, but I wasn't sure how. Okay. So then 65 up to 67. So we're going to move on from 5... Ah, shit, I forgot what we were working on. So 544, 546 then. 546 are your geoemids. Okay. Geoemids. Geoemididae. Geoemididae. I think I'm just going to add it on some note here. Note. I don't want to add in the big-headed turtle as its own unique blah 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 thing. Platysternidae. Note. Platysternidae not represented by clade labels. Okay, that's fine. Okay, if I remember correctly, then we did go down that whole 544 thing. Okay, let's look at 608. These are your tortoises. These are definitely your tortoises. Let's see if that's all monotypic, though. So, we got your Testudinidae. Testudinidae. Okay, Centricales. Does this include? Yeah, okay, definitely includes Gopheros. Okay, so 608 is just Testudine. Cool. 608 Testudinidae. Always making sure I Testudinidae. Testudinidae. Cool. Okay, that one was very easy. So now let's look into 672. Six, 7, 2 has a lot of the Asian species, Badgers and whatnots. So if we go back to the Testudines family, okay, we know we're not including this. I included sea turtles in here. We got Chelydridae. So really this is just a split now between Caretocheliddae and Dermatocheliddae. Wait. No, I'm missing stuff. Hold on. Oh, wait. Hold on. This might be all the Geoemetidaes. Rhinoclemis? Yeah, I know this text is almost impossible for you to see. Okay, but does this also include Badger? It does include Badger. Okay, so 74 is Geoemetidae, but then where did I mess up? So this should be the box turtles. Wait. It might just be all Emidae. Maybe that's the issue that we're having here. Shit. Hold on. I might have confused myself. 1 second. So, Emidae. So where the fuck are the terrapins? So where are the... Wait, hold on. Maybe I just got all my... Yeah, okay, terrapin. Why wasn't it showing up? Okay, so they are in Emididae. But why is this not... I'm just dumb, it's just right there. Jesus Christ. Okay. So, this is fine. We can fix this. I believe it's just 560. And then we would remove this one. I think it's going to be 545 is the thing. Okay, so now let's remove these labels. Yep, Emidae looks good. Testudinidae, Geoemetidae, Pleurodira, Trionychidae, these two, which are all sorts of fucked up.
Now we will just add in some stuff. So Pleurodira. Let's just make this one green, steel blue. Let's look at colors in our. Oh, I'm still in a weird spot. Haha. Okay, we'll be messaging. What? Hmm. Not a lot of critical thinking. Boom, boom, boom. Okay. Bro, wipe your camera before you post. That is so nasty. Okay. Okay. So we have all of this. It is pretty wild how much shit we got. Now let's look and see what this looks like on our Shiny app. Because again, I don't really care about knowing the individual species. That actually looks pretty clean. Not gonna lie. Okay. So then, for example, if we do 45, we expect to see lots of Emetids. This looks so good. Okay, let's finish up all of this. Let's figure out how to add a line break to a label. Line break to label on R. Yeah, this might be weird. Yeah, I thought I could just add it with a hard break. I thought I could just paste it. Levels with line breaks. That's not really what I'm looking for, though. I'm not really looking to do all that. Because it's just like a text level. Oh, okay, that person's gonna do what exactly I did. Because I'm not wanting to add it to like Geom label, I'm wanting to add it to like Geom text. This person's like just at in. Will that really just work if I just do that? So what I'm trying to do is trying to do this one. So if I went here and I went boom, boom, boom. I have a feeling this won't work. Holy shit, it totally does. That's awesome. Okay. So now let's try to fix this whole clusterfuck of things. So let's just put Trionychidae. I think I could just accomplish this with these break texts now. So if I did, we'll do a double line break for this one, and then a single line break for that one. Let's see what that looks like. Okay, so we're gonna need a triple line break there, a double line break here, and then I think we'll just need a singular one here, right? And then Kinosternidae will not have a line break. Let's just assume this will be fine, because also we're going to change all the colors. So, colors in R. Let's start adding some colors. Okay, I think Chelonidae should be aquamarine. I think Chelydridaes, I think they are in... I don't want to do that. Let's do a darker color. Let's do... I like brown 3. Oh no, the Kinosternids have to be brown 3. That just fits them. Let's make this one a dark orchid 1. Let's make Emidids. They should just be green. Let's just make them dark green. Testudines. They should be some type of grayish color as well. Let's do Burleywood. Ooh, wait, what are these? Chocolate. Let's make them chocolate 4. And then the Geoemides, these are the Asian ones. I haven't used red. Let's use red. Fuck it. YOLO. Let's use Firebrick 1. Chelonidae is not a good color. That's very hard to read. Let's make this aquamarine 4. And then let's also add, I just want to add a line break after this, so just so it's a little bit higher. Okay, let's see how this looks on the Shiny app. These two first colors, gold needs to be darker and their color needs to be darker. I think I can also just drop Chelonidae down, so that should be fine. Okay, so Chelonidae, I can just drop you down. Let's make you gold 4, and let's make those ones chartreuse 4. I'm not even going to attempt to spell that. Okay. So, boom, save. We're going to go close that one down. Then server, Shiny up. So let's go to region 33 for example. Now I do want to make these a little bit closer to one another, so let's... I don't know what this is. I legit have no clue what that thing is. If I remove geom tree scale, will that remove that? I want to see where this thing is coming from. Oh. It is coming from that. Okay, so... geom tree scale. So this is setting the X position and the Y position. So if I did Y equals 30, what happens there? I want to hide geometry scale, hide scale. Geometry. No, okay, wait, there we go. Yeah, but you see how it's like adding, it just adds a little thing that I really don't want. To display the tree scale by adding X, tree scale's much earlier, this tree scale. Okay, that's all fine and dandy, but I still don't. Okay, so I do want... Maybe I just want to change the width. Maybe that's all I need to do. Okay. And then let's do this, where we do font size equal to 0 and line size equal to 0. Make color equal to NA? Oh, I totally can. Fuck yeah. Okay. Of the line in the text, line size, width for the length, X and Y for the tree scale position. So what if we made X equal to 0? Oh, Z. X equals 0. The problem is, like, it doesn't really matter how it looks here, it matters how it looks on the server, right? But yeah, I will be ending this stream fairly soon. Just depends. Once this actually looks pretty good, I'll be happy. So if I make... Or maybe I do want to push it up. X is equal to 40. That pushes it up. I just want to be able to push it up a lot closer to the actual map. Just like that.
Do need to lower it though, because Trionychidae is getting cut off. Oh my god, this looks so good. Ah, this is exactly what I needed. Hello.
Hello. Still live streaming?
I am, but I'm about to end it. I
Got some good shit.
got some real good shit. Hold on, I just need to fix one thing.
Some airflow down there.
What?
Gotta catch some airflow in this room.
Never. Why would you ever suggest that? So, doing some like little minor changes still, but look at what I have. So this is my data visualizer. It takes a second to load up
Yeah.
because it's loading in a lot of extra layers that I just added. Yeah. So, what do we got here? We got this map, which I can, move around and like zoom in on and stuff. I have added in canopy results. I have added in my borders of just my regions. I added in the mean edge scores and their count of edge species, which I still need to make look a little bit more distinctive,
Yeah.
but that's whatever. Doesn't matter.
Oh, someone's calling me. Oh, no, never mind.
Okay. I also have this phylogeny, which I now also labeled the major families
Wow.
by their clade. If I select a phyloregion, so let's keep this up. I think this will work. So let's say we do the 45 is the US one, the major US one. Okay. So I still need to reorganize a few things, but yeah, what it does is it draws this.
Right.
It shows me the subsetted phylogeny over here with the species. It's hard. This is the biggest one, so I'm not too worried about the overlapping characters.
Oh.
Then down here, it puts a point of which tips there are.
See?
And
That's
then
cool.
shows me the richness, the mean edge score count. This actually is kind of pointless because if I just hover over borders, it will tell me that and more. But then I added in the ability to turn on and off different bioclim variables. So,
Holy shit.
for example, temperature, seasonality, and mean precipitation for the year.
Damn. Oof.
Yeah. I need to add the scales, but the scales are being kind of annoying, so didn't worry about that too much. But just this visualization, where it's just my borders and the canopy results, it's incredible.
Yeah, no, that looks fucking
So,
sick.
like for example, I can go down here and it's like, oh, interesting. 57, for some reason, has a whole bunch of paleoendemics. So if I go to 57, now I can see which species, where
Yeah.
they're at, and figure out kind of which ones are these paleoendemics on here.
Right.
A lot easier.
And what's that concatenated one to the left? Is that showing you all the...
This is just the subsetted phylogeny,
Uh-huh.
so it's only the species that are in here. So it's not concatenated, it's at all.
Okay. Only showing you the species.
So it's like, these are only the species that are in phyloregion 57.
Okay.
So this is just like they're just like
Got it.
within that group, but then this is why I needed the full view because
Right.
obviously it's like, oh, we got 2 Testudinids over here, an Emid, a Kinastern, and a Pleurodira. So it's kind of all over the place versus something like 45, which again is the US, where they're more here, like they're just
Yeah.
these species. But if we go up to the US,
Hot damn, babe.
yeah. So we can see the mixed endemism. This is, of course, across the Mississippi River.
Right.
Makes a lot of sense. The next bit is to, I don't know. I need to color this a little bit and show it in some way. But I've been needing this visualizer, though. That's the issue. So if I take away canopy, let's see BioClim 1. So temperature. The BioClim ones I actually need to simplify, though,
Mm,
because they are obviously taking a very long time to work.
yeah.
And BioClim 1 has been giving me some weird issues.
Hmm.
Like, and I don't know why.
Yeah. Yeah, I see. It would take me as long as it took Turtles to evolve the code like this. Same.
So does this only work on one thing? Like, that doesn't make sense. Oh,
have
hey,
all
what's
of
up?
them.
Wildlife Brothers just came in. It would take me as long as it took.
Yeah.
Yeah, you just said that.
That's why I read it.
Yeah,
Okay.
it's pretty good. Oh, you read that? I thought you just said that.
Oh.
It's over here, so I didn't see it. What's up, man? Yeah, this is like the final little products of my the research. So this is all just to explore my data better. Where is 32? Where is region 32? Let's turn on the borders view. Let's also turn off BioClim. That might help out. This is probably a very tiny region. Yeah, right up here. Up in Myanmar. Myanmar.
Yeah, wow. So that's pulling out.
Little ones. But what's going on here with the canopy? So that's these two. Yeah, and also it plots
Super
underneath
active.
things. I don't know why. I want the thing to plot on top, and I thought that's what it would do, but it doesn't. It plots underneath, and that's the issue. So, like, it, yeah.
Yeah.
But yeah, so these are nothing. Like, there's no endemism.
Right.
It's, but yeah, I mean, that just pulls out sometimes. Or maybe it's a,
Sanctified virgin.
let's look at it with, I also need to, of course, add in the, but yeah, it's like these two kind of split here. Interesting.
Dang, between. Not even in Myanmar.
Yeah.
It's in, like,
India splits
And-
it. Oh wait, is that following the,
Pakistan?
is that following the borders? No.
No, definitely
So if we do, let's just do the world gray canvas and then remove the borders.
not.
So yeah, it's in Burma and then right outside Burma.
Well,
That's what
it's
it
not
looks like.
It's Myanmar.
Whatever, I don't care. Will this be published in paper form? Yeah, this will definitely be published, and I'm probably going to include a link to this visualizer. So maybe what I'll do today, probably won't, but maybe, is put this up on GitHub, because then I can embed this into my Notion. So embed it into here, which is where I kind of look at everything, which will synthesize basically all of this BS. But yeah, so this is definitely going to be for publication, but I needed to build this visualizer so that I can just better understand what the hell is going on, because this data is so tricky.
That's insane.
But yeah, like this is, oh, I cannot wait to flex this for lab meeting.
I freaking bet. Hey, what have you guys been up to? Anyways, don't care. Look at this.
Yeah, so I made this data visualizer. Yeah, and also talk about the conservation impacts. I can add a lot more to this. Obviously, I can just keep adding on because it's very modular. Like, it's all just here.
Every time I tell you something and I'm like, hey, it sounds like you're doing a lot. And you're like,
I
I know.
can do more.
Exactly.
I will do more.
And that's what you should know. You need to have a stopping point.
Didn't you also just ask me to, like, phone bank? Didn't you ask me
Because I
literally
was
to do more?
stressed.
I know. I just know. I know. Like I told you, with union stuff, I'm not doing extra because I'm already doing too much. That is the start of my stuff, so. Yeah. This was kind of a pain in the ass to get together, though, because I had to do it manually and look up the node labels.
Yeah, it's an R.
Yeah, it wasn't so bad because it's not that many families, but it was like the problem is this is like the stupid thing. Okay, so I just removed the code that does it, but I can plot all the node labels here. So it's like, oh, cool, 672, which is this one right here,
Frickin'
right? Well, that's fine, but like I can extract that clade so that it only plots that one. Very easy. Here's the issue though. It changes the node numbers from the so like it wasn't. So the problem was that it's like, oh shit, what happens if these two are not a perfect split?
Yeah.
Like I know this is going to be 672. I just looked at these species names, looked it up on Wikipedia.
Yeah, Wikipedia's great, huh?
Well, I mean, honestly though, for taxonomy, yes.
No, you're right. They do have the taxonomic stuff.
Because this, it's just like here's the family, here's the genera they have,
Yeah.
like it. And it's probably pretty damn accurate, and I'm not, stressing. But, yeah, this is what I've been working on for the past couple days. But I don't need anything else. Yeah, so, like, there's a lot. It's like 160 lines of code, so it's actually not that crazy bad. Especially when you consider, like, this observe event is just copied and pasted, right?
Okay. Well, I'm gonna do an email. So cool.
Cool. Are you hungry?
Yes.
Okay, I am too.
Mhm.
I'm gonna stop streaming, dude.
You should do that.
What's up?